Good morning, students. In today's class, we will be learning about another unique characteristics or another unique feature of C++ function called function overloading. In our last class, we learned the need for function, how functions are categorized. Generally, functions are categorized into two types, library functions and user-defined function. We also discussed some of the differences between main functions in C and C++, because in C, the main function generally we write just as simply as main, just open the parenthesis, close it, then we write the function body. But in C++, main function is supposed to return a value of int type means, then we write it as int main, then argument. We also learned a new concept called function prototyping. A function prototyping is a type of declaration. Hence, function prototyping is mentioned in the same place of declaration of variable, because that is also a type of declaration. But the purpose of function prototyping is to tell the compiler the name of the function that we are going to call, number of argument the function is supposed to receive, and the data type of each and every argument, and the data type of the return value. All these information will be made known to the compiler through function prototyping. While calling a function, your function prototype and the function call should match in both what? Data type of the argument, number of argument, and also the return type. In today's class, we will be learning about another unique characteristics of C++ function called function overloading. We will be learning about what are the rules we should follow whenever we want to overload function, and what are the advantages of overloading functions. At the end of today's class, you will be able to understand the meaning of function overloading. What is function overloading? How to overload function? And we know that a C++ one concept called polymorphism is there. What do you mean by polymorphism? Using the same thing for many purposes. So we can achieve the polymorphism through function overloading. So in this class, we will be learning about how polymorphism can be achieved through function overloading. Overloading means use the same thing for different purpose. Just like, for example, in one movie, same actor is acting as a lawyer. In another movie, the same person is acting as a doctor. In some other movie, he's acting as a professor. So the same person is doing different roles. So that is also one example for polymorphism. Poly means many, morphism means appearance. So in function overloading, same function, we are using it for different purpose. So we can use the same function name to create family of functions, and each member of each function perform different tasks. So function overloading, another name is function polymorphism. So in function overloading, what happens is we have a family of function, and every function in that family will have the same name, but the difference is each one will have a different data type of the argument or different number of argument, and they may have either the same or different return type. So using the concept of function overloading, we can design a family of function with one function name. Same function name should be there for all the function, but they should have different argument list. Argument list include it. Argument list tells you how many arguments the function takes and what is the data type of each and every argument. So the function, each function in that family perform different operation depending on the argument list in the function call. And so in the case in the function overloading, what happens is we have same function, 3 to 4 example with the same function, but they have either different number of argument or different data type of the argument. But when you call a function, which function is executed? That's a tricky question. So generally what happens is when you call a function, the compiler tries to find an exact match. So tries to find a match between function call and the prototype. Whichever prototype it matches with the function call, that function will be called. Anyway, I'm going to explain the function call overloading with an example also in my subsequent slide. So in order to overload a function, you should remember three things. One thing is you should have many functions with the same name, but the difference must be in the number of argument or the data type of the argument. Even if they have the same return type also, it doesn't affect. So return type does not decide function overloading. For example, if you have two functions f and f, and the first one is taking int as an argument. Second one is also taking int only argument, but the first one is returning float type and the second one is returning character type. Means there the difference is not in the number of argument or the data type of the argument. There the difference lies in only in the return type. In that case, we cannot say that they are overloaded. Okay? So you should follow some rules for overloading a function. One thing is you should have several functions in the same program with the same name. So you have a family of function, more than two function or more than one function. All the function should have the same name, and each function can have different number of argument. In one function, we can have one argument. In another function, we can have two. In another function, we can have three. In one function, no arguments are. So in that case, the difference is 0, 1, 2, 3, etc. Or if the number of arguments are same, at least you change the data type of the argument, then it's okay. Or last one is just by changing the return type, it's not enough to overload a function. Let us take some simple example illustrating function overloading concept. So before overload a function, we have to write the prototype of all the functions in that family. We have a variety, we have a family of functions with the same name. No, in that case, what happens is every function you should first write the prototype. As an example, here I have considered a family of function with a name called sum. The first prototype says that the function sum taking two arguments. First argument is also int type, second argument is also int type, and the return type is int type. Second example, second prototype is again the function name is sum only. Now it is taking three arguments and the return type is int. So the difference between first and the second is in the number of argument. First one is taking two arguments and the second one is taking three arguments. So now we say that they are overloaded. Next, take the third one. Third one says that return type is float, function name is sum. It is taking two arguments only. So now the first one is also taking two arguments. The third one is also taking two arguments. But the difference between first and the third is the first one, the argument data type is int and int. In the second case, if the data type is int and double may, it's okay. Third one, return type is float, function name is sum, but it's taking two arguments, but the data type of the arguments are double and double. Now the difference between first, third, and the fourth prototype is not in the number of argument. In all the three, the number of argument remains as two only. They differ in the data type of the argument. First one it is int and int. Third case it is int and double. Third, fourth case it is double and double. And the last argument prototype also return type is float. Function name is sum. It's also taking two arguments only, but the data type is double and int. So when you look at these prototype, the difference between the second prototype and all the remaining four is in the number of argument. But the difference between among 1, 3, 4, 5 is not in the number of argument, but in the data type of the argument. Now we'll say when you call a function, which prototype is used. When you call a function like sum 10, 10.4 and 8, in that case, the compiler tries to find a match of the function called sum with two arguments. How many functions are there with two arguments? 1, 3, 4, 5. In all the four, the number of argument is 4 only. But here the first argument is float type or the double type, and the second argument is int type. In that case, it does not matches with one because the first one says that both the arguments are int only. It does not matches with the third one because it says the first one is int, the second one is double. It does not matches with the fourth one also because both must be double type. But it's probably you'll have a better match with the fifth one because this is double and this is int one. In that case, it would call this one. So it makes use of the prototype 5. The second example, sum 8, 9.8 means it tries to find a function prototype which has one int argument and one double argument. Means it makes use of third one. Third case, sum 9.9, 2.9, it tries to find a prototype with both the arguments are float type or double type. So double, double. Fourth, next sum 5, 6 means here it tries to find a prototype where both the arguments are int type. Means it makes use of 1. And the last one, sum 2, 3, 4 means it tries to find a prototype which accepting 3 argument. Means this one. So it makes this best matches for 2. So the whichever function is called, that depends on the prototype. So during function call, it finds the best, tries to find the best match, and it picks up, it makes use of that particular function prototype. In many situations, finding the exact match is not possible. First instance, the compiler tries to find a match, exact match, in which the type of the actual argument are the same as that of the prototype. But in many situations, you cannot find an exact match. If the exact match is not found, then some conversion will automatically takes place. Because in C++ or C, character type is converted into int type and float is converted into double type. For example, here the argument is float type, but here we don't have any of the prototype which says the argument is a float type. In that case, what happens is float is converted into double type. So that's the reason 10.4, even though it's a float type, it is automatically converted into double type and makes use of the last one. Or if the argument is a character type also, and if does not find a match for the character then it will try to convert the character into int type and find the match for that one. So you take this example. The first prototype says that the function name is fun, taking two arguments of int type and the return type is int type. The second example, the argument is two only. They are of int and double type and the return type is float type. When you call a function fun a comma 80 means one is character, another one is int. So there is no prototype which says that one of the argument is character type. In that case, char is converted into double. It will take the ASCII code of capital A. ASCII code of capital A will be 65. Now the function call become fun of 65 comma 80 means both of them are integer. In that case, it makes use of this prototype. But the exact match is not found then makes use of some conversions. Char is converted into int type, float is converted into double type. Like that, some other conversion is there that you already studied in your C language. When either of them fail, when it's not possible to find an exact match, and even after conversion also matching is not found then in that case, the compiler tries to use the built-in conversion to the actual argument. There are some built-in conversion. If one of the variable is int type, other one is a float type, int is converted into float type. If one of them is long integer, in that case, what happens is other argument is also converted into long integer. Some conversion takes place. That again, that type of conversion, we call it a automatic type conversion. Example is take a statement called a plus b. Suppose a is int type and b is float type. Out of int and float, float is considered as a higher data type. In that case, what happens? A is converted into, even though we are giving integer value for a, it is converted into float type, and both are it will perform the addition operation with both float type, and the result will be float type. So there are some automatic type conversion rules that you can refer in your C note. If one of the argument is int, other one is converted. One of the argument is float, means other one is also converted into float. Result is float. If one of them is unsigned, other one is also converted into unsigned. The result is unsigned. If one of them is long, other one is also converted into long. Result is long. So in that case, you try to do such conversion. If all the steps fails then the compiler try to do some user-defined conversion in combination with integral promotion and built-in conversion to find a unique match. You need not bother about this type of conversion because generally one of the prototype will be matched with only the first two cases. First try to find an exact match. If an exact match is not found then do some limited conversion. Float is converted into, float is converted into double, char is converted into float. If these two conditions fails then it will make use of these two situations. Let us take one simple example illustrating function overloading. So hash include iostream.h, conio.h, math.h have included 3 header file. See, here I have created a family of function called fun. First function taking one argument of float type, return type is float. Second taking two arguments, both of them are float, return type is float. Third one, 3 arguments are there and the return type is float. So the difference, now we have overloaded a function because we have a family of function called fun, where the difference in not in the data type, it is the difference here in this example is in the data type of the argument. First case it is float 1, second case it is 2, third case it is 3. Now what I will do is I will do 3 different tasks. One is finding the square root, second one is finding the sum of 2 numbers, and third one is find the biggest among 3 numbers. To find the square root of a number, you have to give input as 1 number, output will be 1 number. In that case, you make use of this one. Second case, finding the sum of 2 real numbers. In that case, 2 input and 1 output. To find the biggest of 3 numbers, 3 input and 1 output. So now what happens is, so function name in all the 3, same function fun, if you pass 1 argument, it gives the square root. If you pass 2 argument, it gives the sum of 2 numbers. If you pass three arguments, it gives the biggest of three numbers. So what we are doing is same function, we are using it for three different tasks. Hence, we say that one, the function fun is overloaded. So here, for the first one, input is A, output is R1. For the second example, input is P and Q. Inputs are P and Q, output is R2. Last case, inputs are X, Y, Z, and output is R3. Enter a number. So input the value for A, then you call the same function fun with one value called A, and whatever value the function is going to return, you store it in R1. Next, it is displayed as square root of the input A equal to the value of R1 end line. Second example, enter two number. Here to input the values of P and Q and call the same function fun with PQ, and whatever value the function returns, you store it in R2. You display it as sum of the value of P and Q equal to R2 end line. Third example, you have to input three numbers, X, Y, and Z, and call the function called fun with three argument X, Y, Z, and return value you store it in R3. Biggest of X, Y, and Z equal to R3. So I think you have understood. The first, here I'm using three different forms of the function called fun by passing one argument or two argument or three argument of float type. If one argument is passed, it will perform the task of finding the square root. If two arguments are passed, it will make use the same function to calculate the sum. If you pass three arguments, you make use of the same function to find the biggest of three numbers. So the tasks are different. The function name only is same. Hence, we say that the function fun, F-U-N, is overloaded. Now what happens is, now we have to write three different forms of the function called fun. Return type is float, because return type, in all the case, we have mentioned the return type as what? Float, float, float. First case it is one float, second case it is two, third case it is three. Float, function name is fun, float A, return square root of A. Second case it is return type is float, function name is fun, float P comma float Q, return P plus Q. And the last one is float, fun, float X comma float Y comma float Z. Three arguments, all the three arguments are a float type. You declare another variable called big, which is also float type. Initially, X value is stored in big. So now big contains the value of X. If B value is greater than big means value of Y you transfer it into big. If Z value is greater than big means Z value transfer it into big. So when you finish this if condition, what happens is the variable big stored the biggest among three variable called X, Y, and Z. So out of these three X and value, one will be the biggest. The biggest value will be assigned to the variable called big. Return the value of big. Okay. So far we have studied what do you mean by function overloading, how to overload a function with a simple example. Why we need function overloading in C++? Because it's a unique feature which was not there in your C language. One thing is, function overloading increases the readability of the program. You need not you need not give different names for the function. Because in all the three examples I have given in the previous one, I have used the same function called fun only. So no need to find out or no need to search different name for the function. So actually, it helps in reading the program easily. It saves memory. And the thing is, it helps in creating family of function, the same name for performing similar tasks. Sometimes what happens is, you can use the function overloading to same function can be used to perform similar task. Task is similar, but the argument is different. You can use, for example, there is a library function called SQRT. Same SQRT function, we can use it to find the square root of an integer number as well as finding the square root of a float value. So here what happens is, the purpose remains the same. Purpose is to find the square root, but the arguments is different. So create a family of function with the same name that performs similar task but on different data type. This is one case, one example. So example, all your library function, you can use it, square root, POW, everything we can use it for finding the square root of number or finding the values of A to the power of B, etc. But on different data type. Or you can use the function overloading to create a family of function where different function or the same function perform different tasks. In the previous example, same function fun is performing three different tasks. It is performing three different roles. Same function fun is doing square root of a number. Same function fun is finding the sum of two number. Same function fun is determining the biggest of three numbers also. The second example, function is doing different tasks on different data type. In the first example, in the library function is doing same task on different data type. So that's the beauty of function overloading. You can use the function overloading concept not only to create a family of function that perform different tasks. It will create a family of function that perform similar tasks but on different data types. So in today's class, friends, we have learned what is function overloading. It's a new concept, so which was not there in your C language. The purpose of that concept is to create a family of function for performing either a different task or a same task but on different data type. What are the rules for overloading a function? Rules are they should differ in the data type or the number of argument. Return type does not have any effect. Just by changing the return type, you cannot overload a function. And we have studied one simple example of function overloading. And during function overloading, some rules are first, the compiler tries to find the exact match of prototype with a function call. The exact match is not found, means try to do some automatic conversion. If that is also failed, then it try to do some integral conversion. Float is converted into double type, because if the argument you are passing is float type, but the prototype says that it's double type, means in that case float is converted into double type. Or the prototype I mentioned as an int type, and the argument you are passing is a character type. In that case, what happens if you don't find any exact match for character type, means then it tries to convert char into int, float into double. So it's the second level. If these two fail, in that case, it tries to do some automatic conversion. In C language, you have studied all the automatic conversion. And after automatic conversion also, if it does not found any match, mean then it does perform some user defined conversion. User defined conversion is from typecasting. Typecasting is an example of user defined conversion. So some of the review question are: what is function overloading? How do you overload a function in C++? So generally, function overloading is an important concept in function concept of C++. In examination, one question definitely will be from this particular topic. Write the general rules for overloading a function and explain with an example function overloading in C++. Try to give as simple example as possible, illustrating the concept of function overloading. Your program need not be a complicated one. So I have framed some multiple choice questions on function overloading concept. The first one is: function overloading is also known as polymorphism, prototype, recursive call. None of these. The correct answer is A, polymorphism. Overloaded function differ in number of argument, data type of argument, return type, either ARB. So just that change the return type does not serve our purpose. So they should differ either in number of argument or the data type. Means answer is A, R, B, D. Which of the following is not an example for function overloading? You observe carefully. Float, F, int, comma float. First one is the function name is F, two argument, int and float. Second case also, two argument, same function, same return type, but the arguments are float and float. So that is an example for overloading. Second case, void F, int, comma int. Second one is float F, float. So here the differ in the number of argument. That is also overloading. Third example you take, float F, int, comma int, comma int, and int F, int, comma int, comma int. So here same function name, same number of argument, same data type of the argument. They differ only in the return type. That is not overloading. And last one is double F int, double double. So number of argument is one only. The return type is maybe double, and they differ in the data type of the argument. So the correct answer is C. Identify the wrong statement. Function overloading is a type of polymorphism. True. In function overloading, return type must be different. Wrong. In function overloading, function perform different tasks. True. Library function also can be overloaded. So the correct answer is B. So with this, I'm going to stop today's session. And if you have any doubt, you can free to call me over that number or try to send your queries at least in the comment section of the Google class so that I can refer and answer your queries. Okay. Thank you and have a nice day.